All right, you ready for this? We're going to dive into something pretty wild today. Ternary computers. Ever heard of them?
I'd wager probably not.
Yeah, most people haven't, and that's kind of what makes this deep dive so interesting. We've got, let's see, some research papers, a few historical accounts, even some modern analysis of this almost forgotten technology.
Yeah.
And get this, the Soviets, they actually built one back in 1958, like right smack in the middle of the Cold War, called it Setun.
What I find really fascinating about Setun is uh, it's not just the tech itself, but what it kind of tells us about the forces that shape innovation. It really
Yeah.
challenges our assumptions about what's even possible and who gets to decide what the future is going to look like.
Yeah, for sure. Okay, so for anyone listening who's not a computer whiz, maybe we should start with the basics. So we all know computers use binary, right? Ones and zeros, on or off, like a light switch. But C-Tune used something called balanced ternary, which adds a third option, -1. It's kind of like a light switch with three positions, on, off, and dimmed.
Exactly.
Yeah.
It's a concept that takes a minute to wrap your head around. We're just so used to thinking in binary terms.
Mhm.
But ternary logic, with its inclusion of a neutral state, it actually reflects a lot of natural phenomena, if you think about it. I
Yeah.
mean, things in nature, they rarely exist in just simple on-off states.
Yeah.
There's gradients, cycles, oscillations.
Mhm.
It's all much more nuanced than just yes or no.
So the Soviet computer, it was tapping into something more fundamental, more aligned with like how the world actually works.
In a way, yeah. And it wasn't just a theoretical concept either.
Yeah.
C-Tune was built at Moscow State University by two brilliant minds, Nikolai Kuznetsov and Sergei Sobolev. And they actually used it for real-world applications like weather forecasting and industrial control systems.
Wow. That's amazing. So it actually worked. But hold on. If it was so efficient, and had real world applications, then why didn't it become like the standard? What happened to Setun?
Well, it's a story of innovation meeting economic and geopolitical realities, I guess you could say. To understand Seton's fate, we really need to look at the bigger picture of the time. The Cold War, it was in full swing, and the West, particularly the U.S.,
Yeah.
was actively trying to contain the USSR's economic and technological growth.
So it was more than just competition. It was like an all-out effort to hold the Soviets back.
Absolutely. The West, they implemented policies like Bretton Woods and the Marshall Plan. These essentially excluded the Soviets from participating in the emerging global economic order. And they were also denied access to Western technologies like semiconductors, which were, absolutely crucial for building advanced computers.
So basically, it was like the original tech embargo. Imagine if today's companies couldn't get their hands on like the latest AI chips or something. I mean, it'd be chaos.
Precisely. The Soviets, they were forced to innovate on their own terms. And while this led to some remarkable achievements like C-Tune, it also meant that they were constantly playing catch up in a global market that was rapidly standardizing around Western technology.
That makes sense. But I'm still kind of curious about the ternary logic itself. It seems, counterintuitive at first, but you mentioned that it reflects natural phenomena. Can you expand on that a bit?
Sure. Think about ancient civilizations like the Sumerians and Babylonians. They used base 60 and base 9 systems, which are both divisible by 3. There's even something fascinating about base 9. When you multiply any number by 9, the digits of the resulting number always add up to 9. It's like this inherent elegance and efficiency built into base 3 logic that we've kind of forgotten about.
Wait, really? That's kind of mind-blowing. So ternary computing, it isn't just some like weird Soviet experiment. It's tapping into something ancient, maybe even fundamental to how numbers work.
Exactly, and this connects to the idea that ternary logic is closer to how natural systems operate. Think about the human brain; it doesn't just fire yes or no signals. There's a whole spectrum of neural activity, a complexity that's more akin to a ternary system than a simple binary one.
So by sticking with binary, are we limiting the potential of computing, especially in fields like AI?
That's a question that researchers are starting to explore now. If we could design computing systems that operate on ternary logic, could we create AI that's more nuanced, more efficient, maybe even closer to how our own brains work? It's a tantalizing possibility.
Okay, my mind is officially blown. But let's bring it back to Seton for a minute. If this ternary approach was so promising, then why didn't it catch on? Was it just bad timing?
Timing definitely played a role, but there's a bigger factor at play here: market standardization. The West, led by companies like IBM, had already invested so heavily in binary computing. By the time Seton came along, it was simply too late to change course.
So even if ternary computing had some advantages, it got steamrolled by the momentum of the existing binary infrastructure.
Yes, and this highlights a crucial point about how innovation often plays out. It's not always about the best technology winning. Economic forces, market dominance, even political agendas can heavily influence which technologies succeed and which ones get left behind.
So Setun is like a story about a road not taken, a glimpse into a technological path that could have been. But this brings up a really, really interesting question. Is it possible that ternary computing could make a comeback? Could it still have a role to play in the future?
That's a great question, and one that leads us to some exciting developments happening right now. But for that, we'll need to dive into part two of this deep dive. Welcome back. Last time we kind of left off with this tantalizing question of whether ternary computing could ever make a comeback, and the answer might surprise you. There are some very real developments happening right now that suggest this forgotten technology may have a bright future.
Okay, color me intrigued. What's got you so optimistic about ternary's potential? Is it just nostalgia for like a Cold War underdog, or is there something more substantial going on?
It's definitely more than just nostalgia. Remember how we were talking about how ternary logic aligns with natural processes and even ancient numerical systems?
Yeah.
Well, it turns out that this inherent elegance translates beautifully to some of the most cutting-edge fields in computing today, like quantum computing.
Quantum computing, you mean like the stuff that's supposed to revolutionize everything from like medicine to material science? How does ternary even fit into that?
It's all about the fundamental building blocks. You see, in
Mm.
traditional binary computing, information is stored and processed in bits, which can be either a 0 or a 1. But quantum computing uses qubits, which can exist in a superposition of states, meaning they can be 0, 1, or both simultaneously.
Okay, I think I'm starting to see where you're going with this. Qubits are kind of like that dimmed state in ternary, right? They're not just on or off, they're somewhere in between.
Yeah, exactly. And if we take this a step further, we get something called a quartet. And a quartet can exist in three distinct states, mirroring the -1, 0, and +1 of balanced ternary. This opens up a whole new level of complexity and computational power for quantum computers.
So ternary is like the quantum computing whisper. It provides a more natural framework for harnessing the power of these incredibly complex systems. That's amazing.
It really is, and it's not just theoretical anymore either. There are companies out there actively developing ternary hardware. One example is a company aptly named Ternary Logic, which is creating ternary processors and memory chips. They're still in the early stages, but their work is generating a lot of excitement in the tech world.
So it's not just like a bunch of academics theorizing anymore. People are actually
Sure.
building this stuff. But why now? What's changed since the days of Seton?
A few things. First, our understanding of quantum mechanics uh, has advanced significantly. We're starting to realize that forcing quantum phenomena into a binary framework might be limiting its true potential. Ternary, with its inherent three-state nature, offers a more natural and potentially more powerful way to tap into the weirdness of the quantum world.
Got it. So quantum computing is kind of pushing us back towards ternary thinking. That makes a lot of sense. What else is driving this resurgence?
The rise of artificial intelligence is another major factor. As AI systems become more complex and sophisticated, the need for a more efficient and nuanced computation it grows exponentially. Remember how we were talking about how ternary logic mirrors the way our brains work?
Yeah.
Well, some researchers believe that ternary-based AI could be far more adaptable and capable of learning than anything we can achieve with binary systems.
That's pretty mind blowing. So ternary could be the key to unlocking the next level of AI, the kind of AI that we see in like sci-fi movies,
Yeah.
the kind that can truly like think and learn like humans.
It's certainly a possibility, but of course there are challenges. I mean, the entire computing industry, from software to hardware to chip manufacturing, is built around binary. Switching to ternary would require a massive overhaul. And let's be honest, most companies are pretty resistant to change, especially when it comes to something this fundamental.
It's like we're stuck in a binary rut. You know, we know there might be a better way, but it's just too hard to switch. So what's the solution? Are we doomed to stay stuck in the binary world?
Not necessarily. There might be another player in this game, one that's not so beholden to the binary paradigm. Remember our discussion about the West's efforts to contain the Soviet Union's technological progress? Well, today a similar dynamic is playing out between the U.S. and China.
China. What do they have to do with ternary computing? I thought they were all about like catching up to the West in tech.
They are, but they're also not afraid to challenge the status quo and explore alternative paths. Unlike the West, which is heavily invested in the existing binary infrastructure, China is investing heavily in quantum computing and other advanced technologies. They see ternary computing as a potential opportunity to leapfrog ahead and become a global leader in these fields.
That's fascinating. So China could actually become the champion of ternary computing. It would be kind of ironic considering it was the Soviets who pioneered it in the first place.
It would be ironic, but it also speaks to China's long-term strategic thinking. You see, they're willing to make big bets on emerging technologies, even if the payoff isn't immediate. They see ternary computing as a key to their future dominance in fields like AI, quantum computing, and potentially even space exploration.
Okay, I'm starting to see the bigger picture here. We've got these incredible advances in quantum computing and AI, which seem to be pushing us towards the inherent advantages of ternary logic. And then we've got China, a rising technological superpower that's willing to invest heavily in this alternative path. It's like all the pieces are falling into place for a major shift in the computing landscape.
It's certainly an exciting time to be following this field. It raises some fascinating questions about the future of technology and global power dynamics. Will the West cling to the familiar but potentially limiting binary paradigm? Will China emerge as the champion of ternary computing and reshape the technological landscape?
Yeah. Or
Or will we see a more diverse future where both binary and ternary systems coexist, each serving different purposes?
it's like we're at a crossroads. Binary versus ternary, the familiar versus the unexplored, the West versus the East. The choices we make today will determine the shape of the future. But let's not get ahead of ourselves. Before we start predicting the future, I want to bring it back to something you mentioned earlier. The idea of ternary powered AI being more aligned with how our brains work. Can you elaborate on that? Like what would that actually look like?
Okay, so let's imagine for a moment that we could build AI systems that are based on the principles of ternary logic, systems that are more aligned with the complexity and nuance of the human brain. These AI, they wouldn't just be crunching data. They'd be understanding it, learning from it, maybe even creating art and music.
Oh, whoa, hold on. Ternary powered AI artists. That's getting pretty wild. What would that even like sound or look like?
It's hard to say for sure, but it's exciting to think about. Imagine an AI that can compose music that evokes real emotions, or paint pictures that capture the essence of a moment in time. This kind of AI, it could push the boundaries of human creativity and expression in ways we can't even fathom yet.
That's mind-blowing. It's like we're talking about a whole new level of consciousness in machines. But let's bring it back down to earth for a second. Besides art, what practical applications could ternary powered AI have?
The possibilities are vast.
Yeah.
Imagine medical diagnosis systems that can analyze complex medical images with incredible accuracy.
Yeah.
Catching subtle patterns that human doctors might might miss, or self-driving cars that can navigate complex traffic situations with the intuition and judgment of an experienced human driver.
Oh, so we're talking about AI is not just like faster or more efficient, but actually smarter and more intuitive. That's a pretty compelling vision.
It is, and it's not just about AI either. Ternary computing, it could revolutionize the way we interact with technology in general. Imagine devices that are so energy efficient that they can last for weeks on a single charge.
No more battery anxiety. I like where this is going.
Think about data centers that are a fraction of their current size, reducing our reliance on massive energy-hungry server farms.
That would be a huge win for the environment. What about our personal devices? Would ternary computing change how we use our smartphones and computers?
Absolutely. Imagine interacting with technology that feels like an extension of your own thought processes. You know, your devices would anticipate your needs, learn from your habits, and seamlessly integrate into your life.
It's like a true partnership with technology rather than the often frustrating relationship we have now. It all sounds pretty utopian, to be honest. But are there any potential downsides to this ternary powered future?
Oh, of course, it's important to remember that technology is never inherently good or bad. It's a tool, and like any tool, it can be used for both beneficial and harmful purposes. Even in a ternary powered world, we would still face challenges like data privacy, algorithmic bias, and the potential for misuse of powerful AI.
So it's not a technological silver bullet. We'd still need to grapple with the ethical and societal implications of advanced AI, regardless of whether it's based on binary or ternary logic.
Exactly. Technological progress, it should never be viewed as a solution in and of itself. It's only as good as the intentions and values that guide its development and use.
That's a powerful point. So what's the takeaway here for our listeners? What do we want them to walk away with after this deep dive into ternary computing?
I think the story of Setun is a powerful reminder that progress isn't always linear. Sometimes the most important innovations are the ones that get overlooked or suppressed.
It's a call to be curious, to question the assumptions that shape our world, and to imagine alternative paths.
And most importantly, it reminds us that the future isn't predetermined. It's shaped by the choices we make today. So let's choose wisely.
Well said. On that note, I think it's time to wrap up our deep dive into the curious case of Setun and the road not taken. We've explored a lot of fascinating ideas today, and hopefully we've sparked some new thoughts and questions in your mind.
If you've come away from this deep dive with a sense of wonder and a desire to learn more, then we've accomplished our mission.
Keep exploring, keep questioning, and keep diving deep into the world of ideas. You never know what amazing discoveries might be waiting just around the corner. Until next time.